Good evening to all. Welcome to day 5 section. Today we'll discuss about the how to create the one 2D frame in Stat Pro. 2D structure. Then we'll go for 3D also. Today we'll discuss about how to create the 2D framed structure. Then how to apply the UDL load and the point load. Then go for taking the shear force and bending moment, reinforcement detailing for your beam and column for your 2D framed structure. Okay. The first of all, I simply create a one 2D framed structure. See this? I simply create a one 2D framed structure. Then you go for 3D is a easy one. First of all, you simply create a one 2D. Okay. This is my 2D structure. Okay, fine. Simple structure. I take this only simple 2D structure. Then go for we will take this another structure also. This 2D structure is a 4 meter. This is a 5 meter. This is the ground floor. This is our ground floor. This is a G plus 1. This is the G plus 2. This is the G plus 3. Okay, this is G plus 2, G plus 1. This is our ground floor. This is a 4 meter. This is the 5 meter. Beams will be provided. Then column height. This is a ground floor. Plinth to my ground floor height is a total. I take this 4 meter height from my ground level to below ground level to slab level. Then next to my G plus 1. The ground first floor height is a 3 meter. Same like that. Another 3 floors are 3 meter height. Okay. Another 3 floors are 3 meter. The ground floor only 4 meter. Okay. Our beam is a beam length is a 4 meter and a 5 meter. I simply provided my beam sizes. Okay. Beam size. Simple one is a 4 meters. Okay. This is a 4 meter. Simply converted into feet. 4 into 3.28. 4 into 3.28 is converted as a 13 inch. Okay. Is converted as a 13.212 feet. Okay. Now it's clear. I converted. This is my meter, 4 meter. The 4 meter converted into feet is a 3.28. 1 meter equal to 3.28 feet. Then our beam is a 4 meter. So I provide the 4 into 3.28 meter. Then finally my feet is a 13 feet. Our thumb rule is a 13 feet equal to 13 inch. Okay. 13 feet equal to 13 inch. Thumb rule is a 1 feet equal to 1 inch. Okay. First of all, I take this my trial and error method. I take this 12 inch. Okay. I go for 12 inch. So 13 inch equal to 13 inch. I simply taken into 12 inch. Trial method is a 300 mm. Okay. 300 mm. I simply provided my 4 meter the beam size. I calculated my 4 beams. Width is a 230. Wall thickness. The width is equal to wall thickness. My depth is a 300. Based on my thumb rule, I calculated the depth on my beams. Okay. Thumb rule, it's calculated the depth on my beam. You go for another L by 10, L by 15. It's a formula. The thumb rule is the easy one. 1 feet equal to 1 inch. Okay. Now it's clear. 1 feet equal to 1 inch for your thumb rule. Next beam. The next beam is a 5 meter. Next beam is a 5 meter. The 5 meter converted into 5 into 3.28. 5 into simply calculated 5 into 3.28. Totally 16.4 feet. It's totally 16.4. I taken into 16 inch depth. So okay, it's simply taken into 16 inch depth means 1 feet 6 inches is a 1 feet 3 inches. So 1 feet equal to how many inches? Simple method. 1 feet equal to 12 inches. So is a 1 feet is a 3 inches. Okay. Total 16 inch is converted into feet and inches. So 1 feet equal to 3 inches. Totally I take this 5 meter beam size. Okay. The 5 meter beam sizes I taken into 230 into 350 mm. Okay. 16 inch I taken into 350 mm for my second beam size. This is the first beam. I provided my 4 meter beam 230 into 300, 5 meter beam I taken into 230 by 350. The next I provide the column size. Okay, this is my column size. This is my column. I different into axial, uniaxial or biaxial, different types of columns. This is the center column but uneven sides. I simply chosen for your biaxial or uniaxial column, the based on your conditions. Okay, the first of all you assume and load and moment based on assume your size. This corner column, it's a moment will be high and load will be high. So I take this column. This is I mentioned this column. The C1, C2, C3. Okay, C1, C2, C3. Three columns, continuous columns are there. C1 column, I give this size for 230 into 380. It's okay, 230 into 380. C2. The C2 column, I simply put the assumption 230 into, I give the 300 size also. So the load only will come, but it's the two corners are C2 and C3 are moment will become. So I provided the higher size for my column 230 by 380 and center column only load. So I provided my 230 by 380, something moment is there, but I provided my trial and error method. Okay, this is center portion is the 230 by 300. The corner is a 230 by 380. Okay, this is the main method. Some trial and error, all of us is the trial and beam size also. Sometimes it will be fail. You change your sizes also. There is a trial and error. The first one I choose my size 230 by 380, 230 by 350. Column size through 230 by 380 and 230 by 300. Okay, now it's clear. The next step is I calculate my beam and another beam size and the column size, all of us. This is my column size. I mentioned this 230 into 380. This column size 230 into 300. Then beam size. This beam size 230 into 300. Then this beam size 230 into 450 for all the 350 for mm all the floors. Okay, it will be all the floors. Next one, loads. All are UDL loads. Okay, the all are uniform distributed load. For example, both the ground floors, the ground floor slab will be acting on this 14 kilonewton per meter overall. The next floor, this floor, G plus 2. The G plus 2 floor are acting on this same. The upper portion you go for higher value, load will be less. I taken into 10 kilonewton per meter. Then this load taken into I taken into 8 kilonewton per meter. This is terrace. This is top. No loads are coming. So I provided the 5 kilonewton per meter. So 5 kilonewton per meter. This is a UDL load. This is a UDL load 14, 10, 8, 5 different loads. Then point load. This point load, this beam only acting on this point load. The point load acting on this near the support to 2 meters. Okay, the 40 kilonewton acting on this point load. See, is the 40 kilonewton acting on this all the beams. Okay, the 40 kilonewton acting on this all the beams. This is secondary beams. It's acting on this point load. The distance of the C2 from 2 meters. Okay, distance of the C2 from 2 meters. It's acting on the point load. Okay, it's a 2 meter. Now it's clear. Our beam size will be taken, column size and other sizes also. Then our material. Then our material is I take this M20 grade and steel is a Fe415. Okay. Then I provided my size and load. Then you simply analyze for your structure. Then you go to directly on Stat Pro. Then easily you take this all the values, shear force diagram, bending moment diagram, deflection, reactions values, and all the values. Okay. First of all, how to, there are three methods in StatPro. Okay, there are three methods in StatPro. One is a snap node method. First method is a snap node method. Okay, snap node method. Another one is a structural wizard method. Structural wizard method. Another one is a geometry node methods. Okay, geometry node method. Let's discuss about the geometry node method. The geometry node method only is easy to take the unsymmetrical plans. Most of the plans are unsymmetrical only, not a symmetrical. Unsymmetrical only. So it's used for geometry method. The snap node is mainly used for 2D. The snap node method is used for 2D. The structural wizard is the practicing mode. It's take a equal size, symmetrical structure. Others are you practicing structure means you go for structural wizard method. The second method, practicing, means you go for real structure, go to geometry node methods. Okay, geometry node method. And this is my this is my 2D structure. Snap node method is a easy to create the 2D structures. Okay, let's discuss about the snap node method. The day after tomorrow we'll discuss about the geometry method. Today we'll discuss about the snap node method. How to create this 2D structures in snap node method also. First of all, simply open in your Stat Pro. Okay, simply open in your Stat Pro, then go to new project. Simply click this new project, then go to space. The space, you select your file name, any one name. You put this any 2D framed structure. All letters are in caps. Okay, I simply provided the 2D framed structure. So, okay, 2D framed structure. This is a folder. You save it. Then you change the units. You change the meter or millimeter or inches or feet or anyone's. Okay, I put my unit is a meter, then the weight is a kilonewtons. Okay, once you go to for feet for my building, you simply change the foot. Okay, this is a foot, the millimeter, all the things are there. I simply click this meter, then unit is a kilonewtons. Okay, simply click this next. This is another one method. Simply click this add beam finish. Okay, simply click this add beam finish. Automatically the Stat Pro, the main page will be opened. Okay, this is our Stat Pro main page. This is the first method. This is the grid dialog box. This is the snap node beam method series. This is the icon. This is a easy to create your 2D structures in snap node method also. This is the snap node method. First of all, see this our points. This is meters. Okay, this is a meter. How to identify this? What is the inches and meters are there? Simply go for snap node beams. Okay, snap node beam. Go to edit option. Go to snap node beam. This is a linear one. This is the linear one. Go to edit option. Click this edit option. Go to linear. This is our left and right. This is a 1 meter spacing. This is a 1 meter. This distance is a 1 meter spacing. Okay. This is the x distance is a this direction. 0 to 10, the x distance are the same like that. 0 to 10, this is also y distance. See this, I simply go for my diagram. Total 4 nines. Okay, 4 9 5 4. This is a 4 distance is another one column, 5 distance is another one column. So the 10 is enough. Our height is a total height is a total. This is a ground floor to this is a 4 meter. Another are 3 6 9. Total I need the 13 meters height. But 13 meters height, but it's only in 2 or 10 meter is there, right? 10 meter y direction is a 10 meter, but I need the 13 meters. Okay, but I need the 13 meter. How to increase your height for this area? How to increase your height? You simply go for y direction. The height is a y direction. Simply add this point on 13 meter. See this automatically it's increased into 13 meter. Then you go to create a 2D framed structure. First of all, create the ground floor 2D frames. Our starting point and 4 meter and 5 meter. Click this starting point. Our height of the ground floor is a 4 meter. Click this is a direction 4 meter. Then go to 5 meter. Totally 9. 4 5 1 2 3 4 5. Okay, totally 4 plus 5 automatically totally 9 meters. Okay, totally it's create the ground floor. Then I need a 3 floor g plus 3, right? Another distance of 3 meters is another 3 meter, another one floor, another one floor, another one floor. Total floors are 3 meter. Simply click this. This is the 4 meter, 5 6 7. Okay, 7 meter. Click this automatically. Click this all the points. Then go to next one. Click this. Once you escape, automatically it will be closed. Then once again click this snap node beams. Okay, once again click this snap node. Then another one is here 8 9 10. Simply click this 10. Click this G plus 2. It will be created. escape, click this once again, snap node, then go to 10, 11, 12, 13. Click this is automatically, it's created the 2D structure. So is automatically it's created the 2D structure. This spacing is a 4 and 5 meters. This is a 4, 3, 3, 3 meters. Then simply close it. Click this OK. Then close it. So is automatically it's created the same like a 2D structure. Then how to check your dimensions is the correct or wrong? How to check your dimensions? Go to toolbars. Okay, go to toolbar, go to dimension beams, go to toolbar, dimension beams, simply click this dimensions. Okay, simply click this dimension, click this display. This automatically check this is the 4 meter height. Another, all the floors are 3 meter, 3 meter, 3 meter, all the floors are 3 meter height. Then the spacing is a 4 meter and 5 meter. This is the correct. So first check, you will be create your model in this snap node method. Another one is we will simply check your dimension. Go to toolbars, dimensions, check for your dimensions. Then how to remove your dimensions? Go to toolbars, dimensions beams, remove option, remove. Okay, this is the first procedure. The first procedure to create a model and remove the dimensions. Our next step is applying the properties and all the things. Okay, there are 5 steps will be followed to applying your material in StatPro. 5 steps. Okay, the first one is the material. To apply your material, the first step is a material. The second step is a size. Second one is a size. Third one is a support, what type of fixed support or a hinged support. Then fourth one is the load. The fourth step is a load. The fifth step is a analyze. Okay, these are 5 things to applying for your building. Then simply go to analyze. You take the shear force, bending moment diagram and reinforcement detailing and all the things. One is the material, another one is a size, another one is a support, load and analysis. These are the main things to applying for your 2D structure. Then you go for analyze your buildings. Okay, then simply I go to my stat pro. Simply go for stat pro, then go to modeling. This modeling, go to general. These are the 5 steps. One is the material, property, support, load and analysis. Simply give this all the values, then finally you go for analyze. Then you will take the shear force and bending moment diagrams for your area and reinforcement detailing of this beams and column, all the things. Okay, I simply go for general. The first one is a material. The first one is a material. Simply click this. Our material is a concrete, but it's have only the M27 grade of concrete. The M27 is there. Inbuilt is a M27, but I need a M20 or M15. How to change how to give the new grade of concrete for your material means go to create options. Okay, go to create option. Yeah, I need the M20 grade of concrete. You will put the all the values from code books. You will take the change the different codes M30, M15. You simply refer the IS code books for the young smallest and the Poisson ratio, all the things. Simply with this value, then you will be go for your designs. Then I take the same as go to concrete, go to assign to view. The assign to view means assign all the materials are concrete. I simply click this concrete, assign to view, assign. The first step will be over. The first step is the assign to view. I apply the all the materials. Okay, the all the materials. Our second step. The next step is a first step is a the material will be over. The second step is a size. Okay, the second step is a size step. Go to same stat, go to properties. These are the properties to applying your beams and columns. How to apply the beams and concrete number? You go for define is a concrete number. It's a section database. The section database is you provide the steel section. This is the slab you will be provided. You go for material and thickness. Now itself I simply apply the beams and columns. Okay, I apply the beams and columns for my size. My beam size is a 230 by 300, 230 by 350. Go to define. Go to define the circular, rectangular, T section. All the sections are available. I simply go to my rectangular. Rectangular. ZD is a width. So 230. ZYD is the depth of your beams. Okay. ZD is the width. ZD is a depth. First of all, my width is a 0.23, then our width is a point, depth is a point 0.3. It's a meter. Okay, identify your unit is a meter. The mm means you have go for 300. 300 is only in meters, so you take a convert into meter is a 0.3. Then add. The next one is a 0.35. Another one beam size is a 0.35. Add. So the next one is a column size. The column size also same. 230 by 300, 230 by 380. Same 230 by 380. Click add and 230 by 300. 0.3. Add closes automatically. The four sizes will be add on your property dialog box. The next step is how to apply the materials for your buildings. This is a simple. 2D means you simply select that and apply. 3D means it's difficult. I tell about the another method. First of all, my beam size is a 230 into 300. My beam size 230. This is our beam 230. I simply select. I put my control, then select the all the beams. Then go to assign to selected beams, assign to view. The two option is there. Assign to view means you will be select the all the material, but you simply selected the assign to selected, only that beam one will be selected. But you go for assign to view, it will be all the sizes will be same. So I simply selected assign to selected beams, assign yes. The next size 350. I simply give the control, then select all the things. Then go to assign to selected beams, assign yes. This automatically it will be selected. I selected my beam size. The next one is the column. Column also 380. 380 is a two corners. I simply select this two corners. See this corners and this corners. See, I simply selected the two corners, then go to assign to selected beams, assign yes. This automatically it will be selected. The center column the size will be less, so I selected the center column, assign yes. This automatically I apply my different sizes and material for this columns areas. Okay, I apply the two different sizes for this beam and two sizes for your beams and column. This is step 2. So step 2 will be over. This automatically our step 2 will be size will be apply. The next one is a support. The third one is a support, how to apply the support for your building. The most of us frame structure are using to fixed supports. Okay, all of our fixed conditions. There is a fixed supports. All of us fixed support. The third one. Go to modeling. Go to general. Go to supports. The support is a fixed supports. Okay. The support is a fixed support. You select that support dialog box. Automatically, it will be opened. Automatically it will be opened. Then go to create option. All the types of supports are there, fixed, pinned, fixed, but enforced, all the types are there. This is our fixed or pinned are mostly used. My supports are fixed supports. Okay, my supports are fixed support. I simply selected my fixed, then add option. Automatically the support 2 will be selected. Then my support 2 is a fixed. Then how to apply the bottoms? There are node crushers are there. There are different node crusher. This is a node crusher, this is a beam crusher, this is a node points. First of all I select this node points, control, I select this all the node points. I select this all the node points, support 2, then assign to selected nodes, assign yes. This is our step 3 is over. The first step is a applying the concrete upgrade. The second step is a size will be applied. The step 3 is a support. I directly go to create. Then I apply the fixed support for this material. Then our fourth step. Step 4 is the load options. Okay. Our step 4 is a load. This is our step 4 is a load. This is a load and definition. This is an important one. So how to create the load. There are different types of loads are there. Point load and UDL load for our member in different floors. The first of all, go to load case details. Go to add. The first one is a dead load. Dead load. I simply click this add. Next one, go to live load. Click this add. Close. It's automatically it will be created the load case 1 and load case 2. The load case 1 I added as a self file. The load case 2 I add as a UDL load and a point loads. Okay. I add the UDL load and a point load. The load case 1 I simply add my self feed also. I simply go for load case 1. So okay, simply go for load case 1, add. Simply go for load case 1, add self weight, add close. It's automatically the self weight will be taken. Automatically the self weight will be taken. I simply click this assign to view, assign yes. The self weight will be automatically assigned for this framed structure. This is a This is the main one. First step will be over. Simply go to select, assign to view. The support will be assigned for this materials. Okay. The next one will be apply the UDL loads. Different UDL load is there, right? Different UDL loads. This is our ground floor slab is a 14 kilonewton, then 10, 8, 5. Then 40 kilonewton, it's a point load. Okay, there's a 40 kilonewton. First of all, I simply go to create the different load case 14, 10, 5 something. 14, 10, 8, 5. Simply go to load case, add. Simply go to load case, add. Go to member loads. Okay, go to member load. This is a uniform load, uniform distribution. This is a UDL load. Maximum the slab load will be acting on your load is a UDL load, that is called uniform distribution load. The point load is a concentration load, is a point load. Okay, the first of all I create my UDL loads. The first of all I create my UDL loads. I simply select my uniform. First load is a minus 14. So gravity is a downward. I simply put this minus values. Okay, I simply put this minus value. Simply put this minus value, then click this add. My another load, second load is a 10. This is a kilonewton per meter. Simply go for minus 10. Add. Then next load is a minus 8. Add. This next top floor is a minus 5. Add. This is automatically once you add automatically all the loads will be added on this dialog box. The next one is a point loads. Okay, the next one is a point loads. This is our point load is a 40 kilonewtons. Okay, 40 kilonewton I simply change into the load is heavy. I simply change into 15 kilonewtons. Okay, I simply change into 15 kilonewton for my point load from 2 meter distance. Same like that, 2 meters distance. I simply go for concentration load. The minus 15, I change into 40 is change into 15. I simply change my 15. Then go for my distance. It's a starting point of the column point, then ending with 2 meter distance. I simply click this 2 meter, add, close. This automatically all the loads will be created. Then point load will be created for your building. Then how to apply this? Ground floor is a 14. Next floor is a 10, 8, 5 is a point load is a distance from 2 meter. First of all, I selected the 14 kilonewton per meter. I select this control. I select this two beams. Then go to assign to selected beams. Assign yes. This is simply click this. Next load is a 10. Simply click this two beams, assign to selected, assign yes. The next one 8. Simply click this control, select this, assign to selected beams, assign yes. The next one is the top. Simply click this one and this one. Assign to selected beams, assign. See this automatically load will be applied. Then how to check this load values for your structure? How to check this load values? Go to right click on your mouse, go to labels option. Go to right click on your mouse, go to labels option, then go for load values, then go for load values, apply OK. See this, our load will be visible. This is the 14 14 10 8 5, it will be given. Then go to labels and take this load value, apply OK. Then concentration force is it nearby 2 meter, so 15.15. I simply click this beam, I select this, assign to selected, assign yes. See this automatically is distance from 2 meter. This one I select that, same assign to beam, assign yes. This one select that, assign to beam, assign yes. Then this one I simply selected, assign to beam, assign is automatically is converted into point load also. Then go to right click on your mouse, labels, go to load values, apply OK. Check this, your minus 15 is a point load. Then other values will be given. Our 4 steps are over since automatically. So our simple method to completed our 4 steps. The first one is a material, the second one is a size, support, load, and analysis. All the steps will be over. All the steps will be over. Next step is a combinations. Okay. The next step is a combination. The combination is a dead load, live load. Live load is a dead load and live load into 1.5 is a combination load. Factor of safety, I can enter into factor of safety is a 1.5. The next step is a combination load. Dead load and live load into 1.5 is a factor of safety. How to apply in the stat pro for this factor of safety? Go to load cast details. Okay, go to load cast details, add define combinations. Okay, define combination, there is a normal. I select this two load cast that side into this side. I simply select, go to factor, my factor of safety is a 1.5. Then this is also 1.5. This is automatically our factor of safety is a 1.5, 1.5. I simply click this, add, close. This first of all I give this load is a 15, but now it's changed into 23. All the load is, see this automatically, this is a 14, it's changed to 21. The 15 12, it's a 5 is a change into 7.5. It's automatically converted, multiply into 1.5 is a factor of safety. So okay, now it's clear. First of all, I give the material sizes, then finally combination, then go for analysis. Okay, then go for analysis. Go to analyze, add, close, go to analyze, run analyze, save. Then automatically the stat pro will be analyzed for your structure. Is a no error, zero warning, and zero note. Once you error will becomes, you will be go for rectify and uh, reconnect it, and error also same like that. Once you error becomes, you go to redesign it, and a warning also, that is the main one. You check this, zero warning, zero errors. This is I already told that the stat pro will go for matrix methods. Is automatically is processing on this matrix method, global tripness matrix, and all the things. So at this time, this full 2D structure is analyzed with this take the time is only 3 seconds. But you go for manual, it's take a 2 to 3 hours. It's manually designed for your reaction load, bending moment, shear force, and all the things. It will be manually go for, it's take a 2 to 3 hours. But the stat pro will be only just a 3 seconds. It will be calculated. That is the difference between manual and software also. But you know that how to check the manual and all the things. Okay, manual and all the things. I simply close it. Our next step, the first step will be over. The first step will be applying on the load and others. The step two. The step 2 is a solution will be over. Given data, analyze all the things. Next one is the result. The result will be bending moment. Okay. The first one is a bending moment, all the things. Next one is a shear force. Shear force. The next one is a deflection. Deflection. Next one is a reaction. Reaction. These four things are you will be calculated in the MOS. Once you created the single beam, you will be calculated the bending moment, shear force, deflection, and reaction. The same procedure will be follow on the start pro. Now we see how to take the bending moments and values and all the things. Okay, I simply go for start pro, then go to post processing. The post processing result setup, you take a which load case 1, load case 2, a combination. You take the combination load, the combination only ultimate load. So you take that combination load is okay. You take that combination load. The first of all, I see this bending moment diagrams and values for my beam. So this toolbar, I simply go to bending moment only on Z direction. I simply click this bending moment. See, this is our bending moment for this area. See, this is load will be smaller. So the bending moment also smaller. See, this is our beam bending moment. This is our column bending moment. Then how to see the values? Go to toolbar result. Okay. Go to toolbar, go to result, go to view values. Okay, go to result, view values, go to beam result. Go to beam result is a bending values. I need the bending values. I click this end and midpoint tile. So I click this end and midpoint. Then click this annotate. This automatically this a value will be some constructed. Then I tell about how to see the values. This is our values. Simply click this control, then scroll your mouse. This is automatically your values for your bending moment. This is the top. See, this is our bending moment for three. Already discussed about the manual. There are three cross sections are there. One is the end section. The another one is the mid span. See, this is our end span is a 13. Our end span is a 13, and then another one is a 5. 5 is a mid span, and then another one this end is a 31. So get there. Sorry, another end is a 16. Then this is a column movement. The column movement is a 13 kilonewton is travel to your column also. See this 13 kilonewton, it's traveled to column also. Another column it's also it will be given. Okay. This is the three cross sections. The one is a 13, is a 5, and this beam. See this automatically this is a bending moment will be high. Why the span will be high? The point load will be acting. That is the different will be the bending moment. The moment will be acting on this column also. This automatically your moment will be acting. In this bottom also this is a footing moment. The final is travel to footing moment for this columns. Okay, this is our footing moment for this column. This is a bending. See this difference. The floor by floor, the bending value will be less. The load value will be less. Automatically our bending value will be less. This is the same as the manual and stat pro calculation for your bending moment. The next one is a shear force. The shear force is a y direction. This is our shear force is automatically. This is our shear force. Then go to result view values. Okay. Go to result view value. Then go to beam result. Unclick this. Then our shear is a shear value is a maximum in end also. The shear value is a maximum in end. I simply click this end value. Simply click this annotate. This is automatically your simply scroll your mouse. Automatically it will be shown. This is our shear value is a 19. This is also 21. This is the best shear value. Why like this? The point load will be there. It will be change on this bending moment, shear force, and all the values. Now it's clear. This is our shear force will be high on this beam. This is a less. So 40 kilonewton. This is a 34 kilonewton for your bending shear force. This is shear force value. Then provided the stirrups and all the things also. Okay. This is our shear force diagram, and this is our shear values for your beams. Okay. Now it's clear how to see the shear values and all the things also. Okay, next one, how to see the reactions. The reactions means column loads. The reaction means total loads transferred to footing. That is called reactions load. How to calculate the reaction loads? This is a, now see this is our shears. Then our how to see the column loads. Column loads. Then go for your reaction. This is our in this bottom. This is our side. You simply go for your reaction one. Okay, reaction. Click this reactions. The click this reactions, then go for automatically the reaction will be comes. See this automatically this table. This is our table. Okay. This automatically it will be visible. This is our column load traveling to our beam also. This is our column load. See, this is our 169, 389, and then finally 249. This is our column load based on your loading condition, beam sizes, all the things is travels into beam. This is our beam, first beam. This is our column load. This column load is a 169. This is our direction. This is a 169. Okay, this load is a 169. The center column is a heavy load. See this automatically. This is our 389. This is our column is a 389. Then this corner column. This column is a load transfer to 249. Then finally, the how to take the footing moment. See this MZ. The MS is the footing moment. This is a 9. This is a 5. Then this is also 5. Then how to see this values also. Sorry, values. Simply click this reaction. See this in this side. The table will be visible. See this is your load case combination. This is a first load case. 169 kilonewton acting on your column. Then this is our moment. The next column is a load acting on 389 for your center column. The moment is a 5. The next third column load acting on 241. The moment is acting on this 9. See this how to take your footing calculation. The load is the y direction and moment column moment is the footing moment is the m is the directions. Okay, now understand how to take your column load values and moment values also. Then this is our bending moment, already known that. This is our shear force. This is our reactions values. Then finally see the deflection. This is our deflection. Simply click this. This is our deflection values. This all are in mm. You check this for WL square by 384 EA. You check this deflection for your column beams and all the things. Go to report, view value, beam result, maximum resultant, annotate. So is automatically its deflection will be there. Okay. You check your deflection, center deflection. This is our central deflection. You check your deflection for your beam also. Maximum beam, the center portion deflection. You simply click this deflection, then go to result, go to view value, simply click this maximum resultant. Then you check the any beam stress. How to check your beam stress? Simply go for beam. Select this beam, select any one beams. Okay, go to trusses. Simply click this trusses. Automatically the truss will be formed. Okay, then now I need this which portion it will be truss will be added. You will be select the portion. I need the span 2.3.20 meter. My trusses it will be given on this table also. You will be check this trusses for your beam on this table also. Then graph is a bending moment and shear force. All the graphs will be given. See this our bending and then shear force. All the graphs different scale will be given on this table and forces also same like that. You will be take the bending moment, shear force, reactions, deflections, and beam stresses also. In this same as your 3D tall structures or any structures for your buildings. Okay, this is our second procedure. This is our second procedure is over. Second step. The second step, finally take the value for bending moment, shear force, deflection, reaction. Another one is a beam stresses also. It will be find out in SAT. Just is taken the value is taken into 3 seconds only for all the values for G plus 3 2D structure. But you go for manual calculation, take a 4 hours or 3 hours. Okay, this is a concept with manual and stat. The next step is a step 3. Step 3 is a designs. Okay, step 3 is a design. Step 2 is a analyze. The analyze step one is a data. Step one is the given data. Step two is the analyze. Step three is the design. Okay. Our next step three is the design. The step three is the design. So you will be give the column details and beam details also. Apply the column details and beam details. Will be apply the grade of concrete for your column and beam also. Fe4 and 5 and steel or grade of steel also. You apply the grade of concrete and grade of steel. Then you provided the maximum reinforcement for your beam and minimum reinforcement, then percentage of longitudinal reinforcement. That type of values will be entered in your design. Finally, you take the reinforcement detailing values and all the things. Okay, then design finally it takes the all the values. Now it's step three. The step three is go for design. This is the one design is there. Next tomorrow we'll discuss on this briefly on advanced concrete design also there. Now itself is design the concrete. So normal concrete. And tomorrow will be discuss on advanced concrete design. Then take the detailing diagram for your beam and column also. Detailing diagram for your beam and columns. Okay. Then how to design your beam and column? The first of all go to modeling. So okay, the first of all go to modeling, go to general, go to general, go to design, go to general, go to design, then select your timber, aluminum, shear wall, steel, or anyone. You simply select that. I design is a concrete design. I select that concrete, automatically the dialog box will be shown. Automatically concrete design whole structure, the dialog box will be shown. You simply go for first your current codes. Okay, the first your current code, simply go to our current code is the IS456. Okay, our current code is the IS456. I simply select this code. Okay, simply select this code, our IS456. Then you go to select parameters. Simply select this select parameter means what are the values will be given for your beam and column design. That is called select parameters. What are the values will be given for your beam and column design. First of all, I select this select parameters. This is selected parameters. I simply select this. Now I select one by one. I need the compressive strength of concrete. Okay, this is my compressive strength. Then I selected the F5 yield strength secondary reinforcement. Then I provided the maximum main reinforcement. Okay, the next one is the maximum main reinforcement. The next one is the maximum secondary reinforcement. The next one I need this maximum secondary reinforcement. Then percentage of longitudinal reinforcement. I need the percentage of longitudinal reinforcement. The another one is the arrangement of reinforcement. Then you need anyone, you will be take it as a no problem values. Okay, I take this only Fy, Fc maximum minimum percentage of longitudinal reinforcement, arrangement of reinforcement. That's only I take this. I simply click this OK. I take this all the values. I simply click this OK. Then go to I select this name only. Then I put the values. How to put the values for your beam design and a column design? You simply go for define parameters. Okay, define parameters. You will be give the one by one values, but it's a kilonewton per meter square. But our grade of concrete or anyone is a newton per mm square, right? Newton per mm square. You simply go to tools, go to set current input units, go to tool, set current input units. I change my units. Okay, I change my units. My length is a millimeter, my unit is a newton, newton per mm squares. Okay, my millimeter newton, I simply change this millimeter per newton. I simply click this OK. Then define parameters. Define parameters. I take this M20 grade of concrete for my beam and column. Simply click add. Once you click this, automatically it will be added. Next one is the Fe415 is the 415 grade of steel. Add the secondary also Fe415. I simply click this FE415. Then maximum main reinforcement. This is our maximum main reinforcement. I maximum is I go for 16 only. Simply click. At the minimum I go for 12 only. 12 mm. My maximum is a 16. Minimum is a 12. I simply click this 12 only. The ratio, the longitudinal percentage will be allowed. I give the 4 percentage only. I simply give this 4 percentage will be allowed for my column design. I simply click this 4 percentage add. Then go for reinforcement. Reinforce arrangement for your column. The two face distribution or longitudinal reinforcement column along 4 faces. You will be need the 2 faces for your major axis or minor axis along with the 4 faces. I simply click this along with the 4 faces. I simply click add close. See this automatically this value will be there. Then how to apply the values on your structure? First of all, I click this M20. The M20 is a Beeman column or same grade. Okay, M20 is a Beeman column. I simply click this M20, assign to view, assign yes. Assign to this is all same like that. FE4 and 5 are column and beam are same. Select that, assign to view, assign grade of concrete, assign to view, assign yes. The maximum steel also same. Assign to view, assign all the next one, assign. This is also minimum also same for my column and beam. The next one is a ratio. I will delete the one. Two ratios are there. This is a ratio. The ratio only the suitable for your column. So how to select the column position? Go to select tool, beam parallel to y direction. The beam parallel to y direction, the automatically the column position will be there. Then go to assign to selected beams, assign yes. Then our reinforcement for my column, same like that. Go to select beam parallel to y direction. Go to assign to selected beams, assign. See this first of all, it's apply the all the material for this areas. Okay, all the materials I yeah, all the parts are available. Okay, all the parts are available. See this, the top reinforcement only given in this higher reinforcement. The bottom will be in compression, then also in top zone. This is a reinforcement. It provided the top zone 4 bars in 10 mm dia, the 2 bars in 12 mm dia. It will be provided. See this is our stirrup spacing. The 200 mm. This corner is a 190 mm center to center spacing for your stirrups also. The next beam, see this automatically this beam is a 5-meter beam. The sizes will be given. The size is a 230 by 350. This cover is a 25 mm. I taken the 25 mm. This beam size. This is our top reinforcement. This is our top reinforcement. It's a 668 AST value. I simply I give that your concept is understand. See this for assumption. I show that how to take this top reinforcement, bottom reinforcement. I simply draw this one beam, fixed end beam. This is our fixed end beam. See this automatically. This is our fixed end beam. This is automatically. This is our bending moment for your fixed end beam. This is our bending moment for your fixed end beam. Then this is a maximum moment. This is the maximum for 15. Sometimes it will becomes 10, and this is a 20 something. Okay, 20 moment. This is a moment will be high. So AST this is a top reinforcement zone. This is a bottom reinforcement. Okay, this is a top reinforcement. This is a bottom reinforcement. The AST will be high. So the moment will be high. The AST will be high for approximately 600. Is a 10. Approximately 300. This is approximately 700 X AST value. See this. Now it's clear. The bottom zone, this corner only moment will be high. So the AST will be high. The center portion is the moment will be there. So center portion, the AST will be there. Same like that, follow on this concept also. The same concept will be follow. See this automatically. This is a moment will be high. The automatically the AST will be high. Then the bottom portion also moment. This is center portion. The moment will be high. then this is our top portion. Automatically this is the portion will be high. This is the same concept, it will be follow on this stat pro also. Then you go to design your AST values is automatically, but you do not take this reinforcement, you directly take this AST value, then calculate this reinforcement. Otherwise you go to directly take the moment and calculated the values in manually is okay. Next beam, these are the layers are given. This is stirrups, these are same stirrups for this, two-legged stirrup for this all these areas, okay. The next one also same like that beam, same, this is our see top moment, the bottom moment and the top moment also. This all are beam designs, okay. This all are beam designs. See this concept, the same like that manual and stat pro also same one. The next one is a column design. The column design already told that as per IS for phases all the things. Our grade of concrete is a M20. Our 415 secondary also 415. Our column length is a 4000. Then cross section 230 by 380 is a 40 mm. Our column is a short column. I already told that how to create, how to know that the type of column, short column or long column. You go for your total length of your column, then minus your depth of the beam, then go for effective length, then you calculated the column length is a short or long. The previous section you will be known that how to calculate the short column or long column greater than 12 or less than 12. Then all column are braced columns, okay. All column, this is our required steel area, this is a required concrete area. Then main reinforcement, the main reinforcement, it will be provided the 4 numbers of 12 bars, okay. The 4 numbers of 12 bars, the percentage of steels. This is a tie reinforcement, it provided the tie reinforcement for 190 mm center to center spacing. This is automatically this is a moment and all the values will be. Then the column will be too easier in this section, okay. This is some difficult to see in this column values. Simply go for your stat, click this column, see this automatically click this column, go to your concrete designs, okay. Click to your concrete design, see this automatically this is our concrete design. This is our column number, there 4 numbers will be provided. This is our load acting on this column is a 240, it will be given 240. Then you go for your moment, this is a 20 moment will be acting on this columns, okay. This is a column moment, beams transfer to column moment, this is 20. Then next one is the your grade and steel will be given, this is a AST required, this is 0.51. The minimum AST value is 0.85, but it's a 2 minimum, so you change into 0.85 values, okay. This is the main one. Then selected the another one column, go to concrete design. This is our load acting on this column, this is a moment acting on this column is a 15. Then you go for AST value, this is the reinforcement for your columns also. This is automatic, this is the method to seeing a reinforcement detailing, all the detailing for your beams and column method. The simply supported, it will be no moment fill on this sections, okay. Now it's clear how to analyze your 2D framed structure, then how to see the manual values for your bending moment, shear force or stirrups are like, then how to check the column values and all the things also. Now it's clear. Understand this concept, how to analyze the maximum for your manual and stat pro also. This is the simple design for your 2D framed structure. The tomorrow will be discussed on advanced concrete design and another one 3D structure also to apply the slabs and footing also. We'll create the how to create the applying the slab, one-way slab and two-way slab. Then will we go for your footing design and all of us. Okay. Okay. Once again, thank you all. Please fill your. I put in the feedback form in chat box. Please fill this chat box. It's only for 5 minutes validity. Only for live persons.